Okay, in this video, let's discuss the third practice exam. Problem 1. We have y is equal to negative 3 sine 2x plus pi over 2. Yes, I copied right. And we're looking for the amplitude, period, and the phase shift. Amplitude is absolute value of this coefficient is equal to 3. Period is 2 pi over this quantity is equal to pi. And the phase shift, to write phase shift, you need to factor out number 2, you get pi over 4, and subtract the negative pi over 4. Okay, so the phase shift is negative pi over 4. So it's a 2 times x plus pi over 4, and plus becomes a minus negative. Okay, so this term you have to be careful. And then we graph the function. We label the key point. What are the key points? So you let 2x plus pi over 2 equal to 0. You find x equal to negative pi over 4. And this expression is 0. Sine 0 is 0 times negative 3 is 0. 2x plus pi over 2 is pi over 2. You get x is equal to 0. And this whole thing is equal to pi over 2. Sine pi over 2 is 1 times negative 3 is negative 3. 2x plus pi over 2 is equal to pi. X is pi over 4. Sine pi is 0 times negative 3 is 0. And 2x plus pi over 3 is 3 pi over 2. X is pi over 2. Then y is positive 3. Sine 3 pi over 2 is negative 1. Negative 1 times negative 3 is positive 3. And 2x plus pi over 2 is equal to 2 pi. X is 3 pi over 4. And y is equal to 0 again. Sine 2 pi is equal to 0 times negative 3 is 0. Okay, so let's try to sketch it. So we have the maximum value positive 3, minimum value negative 3. So 1, 2, 3. This is negative 3. 1, 2, 3. This is a positive 3. We start from negative pi over 4, and then we reach the 3 pi over 4. So assume this is a negative pi over 4. 0, pi over 4, pi over 2, and 3 pi over 4. And at the negative pi over 4, y is 0 here. At 0, y is a negative 3. And then 0, positive 3, and 0 here. So you just sketch it with a smooth curve. And this is a 1 period. For the exam purpose, you only need to sketch this 1 period. That's enough. Label those points clearly, the key point. Label them. You see here you have those 5 key points. All right, so this is the first problem. And second problem, we're looking for the exact value of a tangent of sine inverse of negative square root of 3 over 2. Okay, so let theta be sine inverse of negative square root of 3 over 2. Then we know theta is in the fourth quadrant. It's negative pi over 2 and 0 because it's a negative value. Sine inverse of negative value is in the fourth quadrant. Sine inverse of positive value is in the first quadrant. Okay. Okay, it's a negative value, and we know sine theta is negative square root of 3 over 2. So we try to sketch the graph, a right triangle. Here is the square root of 3 opposite. hypotenuse is 2. By the Pythagorean theorem, you can compute the adjacent side is 1. And the theta is in the fourth quadrant. We know cosine theta is positive. So cosine theta is 1 over 2. Adjacent over hypotenuse. Tangent, so we're looking for tangent theta. Tangent theta is a sine theta over cosine theta. So it's a negative square root of 2, negative square root of 3 over 2 over 1/2. It's a negative square root of 3. So this is the answer. So we look for the cosine and we do the ratio to get the tangent. All right. So first two problems. Problem 3, establish the identity. So we want to establish the identity. It means you cannot write equality from the beginning. I copy it. So here I do not do it. I just copy the formula. Okay. This is a problem. I don't say I start from here. This is a problem. So I start from here. The left side is complex, so let's check. The left-hand side is equal to this. Sine theta to 4 minus cosine theta to 4. Okay, for the denominator, let's leave the numerator there because numerator does not give us any suggestion. But denominator, a to 4 minus b to 4. You can consider it as a square minus b square. And for the square, remember a square minus b square is a minus b, a plus b. Okay, so here it becomes a square minus b square and a square plus b square. If you have a to 4 minus b to 4. So this denominator, let's keep the numerator. And consider the denominator. Denominator sine to 4 minus cosine to 4. It becomes sine square minus cosine square times sine square plus cosine square. Right? And you notice that sine square plus cosine square is equal to 1. So it becomes 2 sine theta minus 1 squared over over sine theta square minus cosine theta square. All right, so we have this formula. And then let's check. Here you have sine, you have cosine. In the numerator part, you only have sine, you don't have cosine. So let's try to get one cosine. So this is a way to get one cosine. Here you have two sine, so write two of them. Write two of them separately. And sine theta square minus 1. Remember, sine theta square plus cosine theta square is equal to 1. So if I move 1 to the left side and the cosine to the right side, so sine theta square minus 1 is equal to negative cosine theta square. So this part is actually equal to negative cosine theta square. You see it? This subtraction give you the negative cosine theta square. So it's a sine theta square plus a negative cosine. So sine theta square minus cosine theta square. The denominator is also sine theta square minus cosine theta square. So you cancel one copy. So you get sine theta square minus cosine theta square. Only one thing. All right? And then you compare it with the right hand side. Right hand side is 1 minus 2 cosine theta square. So it does not include the sine. So let's check this. Sine theta square, you see, sine theta square plus cosine theta square is equal to 1. So you move cosine theta square to the right side. It's a 1 minus cosine theta squares. So you replace this sine theta square by 1 minus cosine theta square. Okay, so this is the right hand side. So you start from left hand side, you do the algebraic computation, you reach the right-hand side, you finish the proof. Okay? So you establish the identity, which means you build it. You do not start from it, you build it. Okay? This is the third problem. Fourth problem. Find sine alpha plus beta if sine alpha is 4/5, alpha is between 0 and pi/2, sine beta is 5/13, beta is between pi/2 and pi. Okay, this is in the first quadrant, this is in second quadrant. To find the sine alpha plus beta, the formula is sine alpha cosine beta plus cosine alpha sine beta. So we already have sine alpha, sine beta. We need cosine alpha, cosine beta. Let's do them one by one. Sine alpha is 4/5. Alpha is in the first quadrant. So we know cosine alpha is positive, and alpha opposite is 4, hypotenuse is 5, so the adjacent is 3 by the Pythagorean theorem. This is a right triangle, so cosine alpha is adjacent over hypotenuse. Okay, so this is cosine alpha. Similarly, sine beta is 5/13. Beta is between pi/2 and pi. This is second quadrant. In the second quadrant, cosine is negative, and the opposite is 5, hypotenuse is 3. You check the adjacent. Adjacent is 12. You check that 12 square plus 5 square is 13 square. It's 104, and 25 is 169. Okay, so you get the other, the adjacent side is 12, then cosine, this is beta, sorry. This is cosine beta is equal, it's negative, negative 12/13. It's negative, it's less than 0. Okay, so you get cosine alpha, cosine beta, sine alpha, sine beta. So sine alpha plus beta is sine alpha 4/5, cosine beta negative 12/13 plus cosine alpha 3/5, sine beta 5/13. So it's 65, negative 48 plus 15, 65. So it's a negative, what's this? It's a 33, negative 33/65. Well, assume I do it correctly. All right? Yes, that's right. So this is a problem 4. This is problem 4. Problem 5, we solve the triangle. Solve the triangle means we need 3 angles, 3 sides. Solve the triangle. A is 40 degrees, B is 20 degrees, A is equal to 2. A is equal to 2. Then from A and angle A and angle B, we can see that angle C is 180 minus 40 minus 20 is 120 degrees. And sine A over A is sine B over B. So you get B is A times sine B over sine A. It is A is 2, sine B is 20, sine 20, sine A, sine 40. So this is a one side. So we have one angle and the other 2 sides. Sine A over A is a sine C over C. So C is A times a sine C over sine A. A is 2, C is 120, so you get a sine 120. A is 40, sine 40. Yeah. So you see we have 3 angles, 3 sides. That's how we call it solve the triangle. All right. So next, we also solve the triangle with all 3 sides. If we have 5, 8, 9, we're looking for other 3 angles. For this, you can only use cosine, law of cosine. Okay, so a squared is equal to b squared plus c squared minus 2bc cosine a. A is a 25. A is a 5, square 25. B is a 8, 64. C is 9, 81, minus 2 times 8 times 9 times cosine A. So cosine A, well, 2 times 8 is 16. 16 times 9 is 144. 144. I move this term to the left side, it becomes positive. And 64 plus 81 is 145 minus 25, 120 over 120. Okay, so I move this term to the left side, 25 to the right side. This subtracts necessitation. Yes, I'm right. And then cosine theta is equal to 120 over 144. It is 5 over 6. Then A is a cosine inverse of 5 over 6. You do the similar thing, you write the any other. B squared is equal to a squared plus c squared minus 2ac, and cosine B, what is B? B is a 64. A is A is 5, is 25. C is 9, 81 minus 2 times 5 times 9, and cosine B. Okay, we move this to the right side, left side, that's 64 to the right side. 2 times 5, 10, times 9, 90. 90 cosine B is equal to 25 plus 81 is a 106 minus 64 is a 42. Okay, it's equal to 42. So cosine B is a 42 over 90. What's this? It's a 7 over 15. It's a 7 over 15. B is a 7 over 15. Cosine B is a 7 over 15. So B is a cosine inverse 7 over 15. So you get A, you get B, then C is 180 minus cosine inverse of 5 over 6 and minus cosine inverse of 7 over 15. So you don't have to use the cosine law to compute the C. You just use the subtraction. Okay? So this is a problem 6. Problem 7, find the area. Be careful, this problem says find the area of the triangle. With the 3 sides, 12, A is 12, B is 13, C is 5. This is a Heron's formula. Area is square root of S minus A, S minus B, S minus C, where S is half of A plus B plus C, the half of the circumference. Okay, so let's apply the formula. If you memorize the formula correctly, then you can just directly do it. So S is 1/2, 12 plus 13 plus 5. It's a 25 plus 5, 30 over 2 is a 15. So S is 15. So S minus A is 15 minus 12 is a 3. S minus B is a 15 minus 13 is 2. S minus C is a 15 minus 5 is 10. Okay, so the area is square root of S is 15, minus A, 3, minus 2, minus B, 2, minus C, 10. What is this? Let's try to do the computation. 5 is 3 times 5, 15, 3 times 5, 3, 2, 10 is a 2, and 5. So you have 2, 3, you move it out. 3, 2, 2, you move it out. 2, 2, 5, you move it out. 5. What's this? It's a 30. It is equal to 30. So the area is 30, whatever unit. All right? So this is a way how to push number outside of a square root. You have two same factor, you move one out. 8. The eighth term, A8 is 8. A20 is 44. This is arithmetic sequence. Okay, arithmetic sequence. An is A1 plus n minus 1 times d. You know the eighth term is 8, 20th term is 44. So you get A1 plus 7d is equal to 8. A1 plus 43d is equal to, oops, sorry, not 43. A1 plus 19d is equal to 44. Okay, sorry, be careful. Here you have to use 20 minus 1, 8 minus 1. Okay, then let's do subtraction. The second equation minus first equation, A1 cancelled. 19d minus 7d is 12d. 44 minus 8 is what is 36, so d is 3. D is 3, plug in here. A1 plus 7 times 3, 21 is 8. So A1 is 8 minus 21 is negative 13. Yes, negative 13. So An is negative 13 plus n minus 1 times 3. N minus 1 times 3. Let me try to justify it. 13, negative 13 plus 19 times 3. 19 times 3 is 57. It's 44, correct. Okay, so I'm just trying to verify my answers. Okay, so this is negative 13 plus 3n minus 3. It's a 3n minus 16. This is the answer. Arithmetic sequence, write it either this way or this way. They are both correct in the exam. Okay, you can write either of them. Problem 9. Determine whether the geometric series converges or diverges. Geometric series converges to A1 over 1 minus r if upper value of r is less than 1. Diverges if upper value of r is greater than or equal to 1. Okay? Okay, now this one, 1 plus 1 over 3 plus 1 over 9 plus 1 over 27. This geometric series has common ratio r equal to 1 over 3. The current term over the preceding term. So it converges. It's less than 1, it converges. Upper value is positive, so upper value is itself. Converges, find the sum. So the sigma k from 1 to infinity. From this sequence series, you know that the first term is 1. A1 is 1. Common ratio is 1 over 3. To k, this is k, my bad. This is k. To the power k minus 1. It is equal to common ratio, the leading term over 1 minus common ratio. It's this. So all right. So problem 9. Problem 10. The principle of mathematical induction. So we want to show this. Principle of mathematical induction basically has two parts. Verify the initial term, go from n to n plus 1. So n is equal to 1. When n is equal to 1, let's check. This left-hand side is 1 times 2. It's just 1 times 1. N is 1. The initial term is 1 over 1 times 2. The terminal term is also 1 over 1 times 2. So left-hand side is 1 over 1 times 2 is 1/2. Right-hand side is equal to 1 over 1 plus 2 is also 1/2. So the left-hand side is equal to the right-hand side. The statement is checked. Okay, that's the first case. Then assume that for n, the statement is true, which means 1 over 1 times 2 up to 1 over n times n plus 1 is equal to n over n plus 1. Okay, so when you get n, integer n, that's correct. Then for n plus 1. For n plus 1, for the next part, let's add one more term. Let's check what is the left-hand side. Left-hand side becomes 1 over 1 times 2. And the final thing is 1 over n plus 1. N plus 1 plus 1 is n plus 2, 1 over it. And its preceding term is n plus 1. Okay, so this is the last term. This is the preceding term. And this preceding term is the last term for the case n is n. For the case for the index n, you add n terms. Here you add n plus 1 terms. Right? Okay, so when you have left-hand side like this, we just consider first n terms. First n terms satisfy the condition. You have n terms, it is equal to 1. It is equal to n over n plus 1. So the first n terms, the sum is n over n plus 1. And then you add the last term to it. Okay, so you add the last term to the sum of the first n terms. And then you try to simplify it. How do we simplify it? The common denominator is n plus 1 times n plus 2. So n times n plus 2. And here, you don't do anything, just put 1 there. Am I right or wrong? Oh, let's check, let's continue. We get n squared plus 2n plus 1, right? N squared plus 2n plus 1. And n plus 1 times n plus 2. N squared plus 2n plus 1 is a complete square, n plus 1 squared. And you cancel n plus 1 from top and bottom. So it is n plus 1 over n plus 2. N plus 1 over n plus 2 is exactly n plus 1, n plus 1, and then plus 1. And this is the statement for the right-hand side when you consider n plus 1. So you start from the statement for n terms, you reach the statement for n plus 1 case, right? In this process, you use your hypothesis. So you get left side is equal to right side. Then you say by the principle of mathematical induction. Principle of mathematical induction. The statement is true for all integer n. All right, its statement is true for all integer. Okay, so this is a problem 10. Problem 11, the binomial theorem. The binomial theorem, we are looking for the coefficient of x to 6, the coefficient of x to 6. So remember, for example, if you have 10, it will be like a to n, a to 9b, a to 8b squared, a to 7b cubed, a to 6b4, and a to 5b5, a to 4b6, 6, a cubed b to 7, a squared b to 8, a b9 and b10, right? You have those terms. The degree of the a decreases, the degree of the b increases. Then you have the coefficient. The coefficient is like n choose k. Okay, the n choose k. So n choose k. So here is a 10 choose, here 10 choose 0, 10 choose 1, 10 choose 3, 10 choose 4. Every time you have that. Okay, so apply this binomial theorem to this problem. The x plus 3 to 10th power, you will have x to 10, x to 9 and times 3, x to 8 times a 3 squared, x to 7 times a 3 cubed, x to 6 times a 3 to 4th power. Okay, you don't write the other things because we need x to 6 times 3 to 4th power. And also we need the coefficient. What is the coefficient? The coefficient means you have 10 and you choose 4. Here it is equal to you have 10, you choose 6. N choose k and n choose n minus k. They are the same thing. It depends on which one you choose. If you choose 4, 3, then it's n choose 4. If you choose 6, 6x, it's n 10 to x, 10 to 6, 10 choose 6. Okay, so the term is like this. All right, and the 10 choose 4 is 10 factorial over 4 factorial over 6 factorial times x to 6 times 3 to 4. 3 to 4 is 81. I just computed. 10 factorial over 4 factorial over 6 factorial is, let's compute this, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's product. 4, 3, 2, 1. And then times 6, 5, 4, 3, 2, 1. You see, this sequence, they're cancelled. And here, 4, 3, 2, this is 24. Right? 2 times 3 is 6. 6 times 4 is 24. Denominator is 24. The numerator, 7 times 10 is 70. 8 times 9 is 72. 72 is 3 times 24. You cancel it, you get 3. 3 times 70 is 21. 210. So it is 210 times x to 6 times 81. And then you put 210 times 81, 8, 16, 17010. So it's 17010 times x to 6. This 17010 is a coefficient. All right. So this is the last problem. Try to do some similar exercise, not just limited to this one exercise. Try to do some similar others and make sure you understand how to find the coefficient of whatever terms. Okay? Okay, we finished this discussion about the practice exam. We will have our real exam on Thursday, right? Okay, see you.